why do we age, first and foremost, and why can't we live to 200 years old?
Why we age, there's something called a naked mole rat that is basically the size of a house mouse. And we use these mice extensively in molecular biology.
That's pretty much because they're the closest thing to the human.
Not really.
Not really?
I mean, the closest thing to human would be
what we usually hear when it comes to cell energy metabolism is ATP. You've just described a three-part pathway. You've got NMN, NAD, ATP.
There's really four ways. So eukaryotic organisms are what we're talking about. Animals are eukaryotes, right? Mammals are eukaryotes. There are genes and enzymes to convert four different things into NAD. So there's something called the de novo pathway that starts with tryptophan. De novo basically means you're making it from scratch. It's like if you were making a cake, or you're making I'm going to make pizza tonight. So I'm doing a de novo synthesis of pizza.
That's the same as because I've read a lot about de novo lipogenesis.
De novo lipogenesis, right. So de novo lipogenesis means that you're starting out with starting materials that look nothing like fats.
Yes.
Like literally, it could be sugar. You're taking sugar and you're breaking it down, and then you can make fat, right? So there's a way to take sugar and make fat. And it's a de novo pathway because the intermediates look nothing like the starting materials and the product looks nothing like the starting materials. So that's how our liver and a few other tissues can make NAD from tryptophan. But the other way is what's called salvage. Just to go back to my pizza tonight, I started last night with flour, yeast, water, salt. If I really was going de novo, I would have some ripe tomatoes as well. But totally de novo means totally from scratch. Salvage means you stop off at Trader Joe's and you get a package of dough, or you get a rolled out, dough. You get a salvageable unit. You get a usable unit of component, a sizable component of that pizza. It's a difference between making a car from, small units versus going to a chop shop. If everybody knows what a chop shop is, there's like a market for like stolen cars or something like that, or wrecked cars. And a chop shop will like pull the things out that can be sold again, right? So salvage would be using those components. And biology is very conservative in the sense that if there's something of value that can be used again, it's going to be used again, right? So NAD is a dinucleotide. ATP is a mononucleotide. It's just one nucleotide. It has one base, it has one sugar, it has phosphates. NAD has two different bases. It has an adenine base, which is the same as an ATP, and then it has what's called a nicotinamide base. And then there's a ribose on both sides, and there's a phosphate on both sides. And people in Washington, the way the American system works, these are small states. It's not New York, it's not California, but everybody's got two senators, Mississippi, Alabama, Georgia, where this was happening. And it went to Washington. They established the Public Health Service because of Pellagra.
Okay.
This is the precursor to the United States NIH. They awarded the first Public Health Service grant to study Pellagra. That's how important NAD is, it turns out. It was awarded to Joseph Goldberger. Everybody told Joseph Goldberger, you're going to go down to the American South and you're going to find an infectious disease that is affecting these folks. He goes down to these places. He goes to hospitals and prisons where there's a lot of people with Pellagra. And in the prisons, he sees the prisoners have Pellagra and the jailers don't. In the hospitals, he sees the patients have Pellagra, the doctors and the nurses don't. And he said, this is not an infectious disease. And he looks at, the doctors and nurses put milk in their coffee and they have fresh food, they have eggs, they have meat. And the people with Pellagra have corn rations, lard, and molasses.
What I think about now is genetics versus epigenetics. because when we look at, with 25,000 genes, if we look at it from a neurodegenerative standpoint, we know that you can switch on these ApoE4 genes, or you can just not switch them on, and you may get Alzheimer's disease, you may not, and it's all dependent on environmental factors.
Yeah, environment is huge.
Yeah.
Right. We have a gene set that can allow us to, live to 120. Although we don't know quite how special the people are that are centenarians, but most of us, probably don't live to our genetic potential because of, environment.
Why do we age, first and foremost, and why can't we live to 200 years old?
Why we age is a tough question, but we do have genetic instructions, right? And all living things have genetic instructions. A bacterium is not going to be a raccoon, and a raccoon, is not going to be a bacterium, although raccoons will harbor bacteria in their gut just as we do. But our genes, they specify the sequence of all of our structural proteins and enzymes, and there are what are called morphogenetic regulators. So animals have something called Wnt genes that give us a front and a back, and a head and a tail, and a right and a left, and 5 fingers on each hand, and stuff like that. Based upon the way particular species evolved, they evolved with a particular life trajectory, let's call it, okay? And it can differ widely within closely related species. So a good example is, you're coming from New York City, so you might have a New York City subway rat in mind if I say the word rat, which is big. But there's something called a naked mole rat that is basically the size of a house mouse. And we use these mice extensively in molecular biology.
That's pretty much because they're the closest thing to the human.
Not really.
Not really?
I mean, the closest thing to human would be a chimpanzee.
Okay.
It's a size where you can put 5 of them in a cage, and there's tremendous genetic tools to do mouse, genetics, basically, is the reason.
Okay, what I would love to understand is, how can we, in your words and everything that you've learned, how can we slow the aging process? I
think that we definitely can age better, right? You can age better, and you can age worse. I think largely it's following mom's advice, to be honest, right? It's a good diet, it's high physical and mental activity, social engagement, sleep, don't smoke, don't do drugs, don't drink alcohol in excess, take medications that you need to take, don't take drugs that you don't need to take.
Drink clean water.
Clean water, right? And so that's almost all of it.
Thank you so much,
All
Charles.
right, thanks. It was a pleasure.